Hello dear students, everyone, and for you I hope you are doing well. So today we will start with the subject mechanics for the SSC 2025. So let's start with the subject, and today we will be studying about overview of forces, composition, system and equilibrium. Okay, so let's begin. Now the thing is that we have to understand the characteristics of a force. What is the characteristics of a force? So the characteristic of the force is, the first thing is that the force should have a magnitude. It means that it will have a magnitude that is 100 Newton, 50 Newton, etc. like this, and this will be acting on a line of action, that is there will be a line of action. Suppose that a force is acting along x-axis or any y-axis. Suppose the force is acting along x-axis, and the force will be 100 Newton along x-axis. This is the line of the axis, and there will be the nature of force, that is the whether the force is push force or pull force. It means that suppose that there is a box, and if we push this box, this will be push, and if we pull this box, this will be pulling forces. There might be the tensile and compressive forces. Push forces are always compressive in nature, and pull forces are tensile in nature in general case. Okay, there might be the changes based on the other factors. Now, the composition of the forces. This is the another part, that what are the various compositions that the forces would be, and the things is related to the composition of the forces. The first thing is that the process of finding out the resultant of the forces. Suppose that a force is given, suppose that this is my axis, and the force is acting at this point with an angle of theta. So there will be the resultant forces if another force is acting like this way. So in this case there will be a resultant force in this direction. So this is the way that the process of finding the resultant is with the help of the parallelogram law and the resolution of forces. So we have to resolve forces in x-axis and y-axis based on that, and we will be having with the forces such that parallelogram law of forces, triangle law of forces. So the first thing is that the parallelogram law of forces. What is the parallelogram law of forces? In the parallelogram law of forces, we see that if a force is acting in this direction, that is OB, and the other force is acting in OA direction, so the resultant force will be R, this one, and this, if we join these both, will make a parallelogram. So the resultant force is equal to, that is R square is equal to F1 square. Suppose that the force this one acting is F1, so F1 square plus the force is F2, so F2 square plus 2 times of F1 F2 cos theta. So this angle is the theta related to the base, or you can see the formula here, that is under root of p square plus q square plus 2pq cos theta, and here you can find out the tan alpha value, that is q sin theta divided by p plus q cos theta. So this is all about the parallelogram law of forces. Now the thing that you have to remember is, if theta is 0 degree, then the force will act along the same line. It means that if theta is 0, then this force is acting in this line, so this force will also act along this line. That will, both the forces will coincide or will act in a single line. If the force is at 90 degree or right angle triangle, so this will form, this is the right angle, and this will form, if you want to make, this will be the resultant forces. Okay, now if there is 180 degree, the force will be in the same line but the opposite in direction. Suppose that this angle becomes 180 degree. Now this force will become in this direction. Okay, this is in this direction, this is in this direction. So these all are the things that you all need to know. What is acting, what are the forces, resolutions. Now the next thing is resolution of forces. How will you resolve the forces? So to resolve the forces, you will have to one single force. Suppose that this is my applied force acting along this way, and this is the theta angle. So in the y direction there will be Fy, and in x direction there will be Fx. So the theta which is attached to the axis will be cos theta, and the theta which is away from the side away from this theta will be sin theta. So the resultant, you can calculate, the resultant is r is equal to horizontal square plus vertical square to the square root, whole to the square root. This square root is whole, h square plus v square, and you can find out the theta value, that is 10 inverse v by h. Now we'll talk about various system of forces. The first system of force is the coplanar force. The coplanar force is that all the forces will be in the same plane. Suppose that this is my plane and the force is acting on this plane. So along only this plane, not in the other plane. So this will be coplanar forces. Now the thing is collinear forces. When the forces are acting on the same line, suppose that this force is acting on this line. I'm just changing the color. If this force is acting on this line, so if you continue this line, then another force is acting on the same line, then this will be called as collinear forces. It means as collinear means the same line, on the same line, common line. So that's why we call this collinear. Now the next thing is concurrent forces. Concurrent forces means all the forces will meet at a single point. Suppose that this is a plane. In the same plane, all the forces are meeting at a point. This is known as concurrent force system. Okay. Now the next is coplanar concurrent forces. Means you see here, coplanar means the same plane, concurrent means same plane, at the same plane all the forces will at the same point. So this is my plane and all the forces are acting on this plane and all the forces are meeting at this plane at a single point, known as coplanar concurrent forces. Now the next one is coplanar non-concurrent forces. It means that the forces will be in the same plane, but they will not meet at single points. It means suppose that this force will act in this direction, this force will act in this direction, this force will act in this direction, and this force will act in this direction. So this type of force system is known as coplanar non-concurrent forces. Now the next thing is non-coplanar concurrent forces. It means that the plane will be the different, but the forces will meet at a single point. Now see this. This force is coming on this plane, this force is coming on this plane, this force is coming on this plane, but meeting at a single point. So this will be known as non-coplanar concurrent forces. And the next one is non-coplanar non-concurrent forces. Means that all the forces will be in different plane, but they will not meet at a single point. Suppose that in this plane, this force is acting, in this plane, this force is acting, but not coinciding or not meeting at a point. In this plane, this force is acting, but it will not meet at that point. So this will be non-coplanar non-concurrent forces. Now the non-concurrent forces, it means that the forces will be in the same plane, but they will not meet at single point. So this is non-concurrent forces. Parallel forces means if a force is acting on this line, similarly another force will act parallelly to the above one or the previous one. So this type of force system will be called as parallel force system. The next one is like parallel forces. Here like means if a force is acting in x direction, positive x direction, then another force will be parallel to the previous force and it will also act in the same direction. So the direction will be the same. Unlike parallel forces, here forces will be parallel, but the direction will be different. You got it? Now the next one is non-parallel forces. It means that forces will not be parallel. They might be here and there. Now the next one is the equilibrium of forces. The equilibrium of forces is that if we consider anything, if it is in equilibrium, then the resultant of the forces will be zero. That is the summation of horizontal forces in the x direction, sum of all the forces. Suppose that this is a beam and the force is acting like this way. If this system is in equilibrium, then all the horizontal forces as well as vertical forces, the sum of all the horizontal vertical forces as well as in the movement will be the zero. Now the next one is Lamy's theorem. What is the Lamy's theorem? So Lamy's theorem is valid only and only for the three coplanar concurrent forces. It means that the forces will be in the same plane and they will meet at a single point. So this is the 3 coplanar, not more than 3, only 3, because this will act at only 360 degree, and each force will be proportional to the angle, that is opposite side of angle. Suppose that this is the force and this will be proportional to the theta, that is the gamma. Means we can say that C sin gamma by beta, B sin beta, A sin alpha will be the equal. So this formula is for the Lemaire's theorem. From this theorem, you can calculate the values. Now, for the Lemaire's theorem, you can see this is only applicable for the coplanar concurrent forces, and that will be non-linear, not the linear one. So this is the things that you have to note. And in equilibrium condition, the angle will be made at 120 degree. Means that the angle will be 120 degree, then this force system will be in equilibrium. Now the moment of force is that the moment is the rotational tendency of a force about any fixed point. Suppose that this is a lever and this is my hinge point. If we put a force at this side, this will rotate along this way, isn't it? It will rotate. So this is the perpendicular distance, and the force moment will be equal to the force applied to the perpendicular to the beam or any of the structure. That will be the moment. So moment is equal to force into perpendicular distance. So the unit is Newton meter. Now the Wegener's theorem. What is the Wegener's theorem? Wegener's principle or Wegener's theorem states that the resultant due to the moment of the resultant and the moment due to individual forces. Suppose that this is individual force and this is individual force. And if we calculate the resultant of this, and suppose that we are calculating moment about over any point, then the moment due to resultant force will be equal to the sum of moment due to this and due to this. So moment due to resultant is equal to sum of moment due to all the forces. The next is principle of moment and couple. The principle of moment is that this is the extension of Wegener's theorem, and the couple is what if we put two equal and opposite forces. Suppose that in the steering, what you do, you put the force in this way and you put the force in this way, and if you put equal forces in both the direction, then it will create a couple and it will rotate. So this is known as couple. Okay, twisting of a screwdriver, turning of cap, turning of tap water, these are all the examples of couple. Now the lever and the principles. What are the lever? So lever is nothing. This is a beam or a rod pivoted to a fulcrum that is rotated and rotated about any points. You can see here in this picture. So it operates. Suppose that this is my first class of lever. Here both the part will be approx equal, the fulcrum and the effort part. Suppose that if you put the effort, the load will be in this direction. The second class is here, load will be at the middle and this will be, you can see the example of your in the platform or in these railway junctions, the coolies are putting the vehicles that they have, might be the, in case of example of bullock cart, or you can say that these are the examples of second class lever, or here is the example that is a knife is an example of your first class lever. And the third class lever is that here will be the hinge and you will have to put the effort at this point and load will be at this point. So this is an example of you, one hand is at your this position and another hand is at your this point, and you put these materials from this, so this is the load. Now all these things are here. In this case, the first class, the fulcrum will be in the middle, example is the scissor, and in the second class, paper cutter, wheelbarrow, nut cutter, nutcracker, these are the example of second class. And third class effort in middle class, efforts are in middle position, as you've seen in this previous slides. So fishing rod is an example of third class. Now, what is the mechanical advantage? The mechanical advantage is the load divided by effort. If you put less effort, and you can get a lot of large amount of force, then your mechanical advantage will be high. Okay, suppose that if you are putting only one hand and you can lift 50 kg of weight, then this is the mechanical advantage. So this is the another formula, that the effort arm divided by load arm. What is the load arm and what is the effort arm? These are the examples of mechanical advantage. So for the today, this is all. Thank you. In the next session, we will continue this mechanics part. So if you like this, join the session and you just learn how to crack SSC examinations. So today is the basic part of this mechanics, and for the next session we will continue this. Thank you. Have a nice day. Take care. Bye bye.